Right. So we're now going to move away from right angle triangles. So before we would have had this sort of a setup in our trigonometry where we would always have had a right angle triangle. So we're now going to move into areas of triangle beyond or trigonometry beyond the junior cycle. So we're now going to start looking at triangles that are no longer right angles. So we could look at this triangle here. It's very hard to draw a triangle which isn't right angle. So I think that looks like a right angle up there. So I want to draw a triangle that's not right angle. So maybe draw something that looks like this. Okay, and that's a bit too small for me. So I'm going to try and do something fancy here. I'm going to try and blow this up. Look at that. Okay, couldn't do that with a regular whiteboard. Okay. Turns out the pandemic has its uses. Right. So, now, so we have some triangle. It's a non-right angle triangle. And we need to be able to talk about this triangle. Okay, so there's two things in this triangle. There's angles and there's sides. And we need to be able to talk about each of these things individually. So I'm going to call this angle down here the angle A. So I give it an uppercase A. So that's the angle A. And because it's an angle, I call it an uppercase letter A. Now, because this is the angle A, that means that the side opposite it, so the side opposite the angle A, is also called A, but this time it's given a lowercase a. So the side that is not touching the angle A, the side which is opposite A, we call that lowercase a. So we have big A, which is angle, and small a, which is a side. Similarly, if I call this guy here B, if I go through the triangle to the side opposite, I call that lowercase b. So there's the angle B and there's also the side B. The angle is the uppercase B and the side is the lowercase b. So you're probably able to guess what's going to come next. This guy up here, I'm going to call him capital C or uppercase C, and that means that the remaining side must be lowercase c. So in our system of naming things in a triangle, angles get capital letters, sides get small letters. So there's the difference between big B and small b is a side, big B is an angle. And that's kind of, you would have seen this before when we would have had Pythagoras. Pythagoras was always a squared plus b squared equals c squared. And these are all lowercase because Pythagoras has to do with sides. Okay, so sides get small letters, angles get big letters. And that's going to be important for where we're going. Now, we have this formula that tells us the area, and let's take a look at the thing from the log tables. So if any of you have a set of maths tables with you at the moment, and you go to page 9, so page 9 of maths tables, you will see that there's a triangle drawn for you, and the triangle looks like this. And in that triangle, there's the sides A, B, and C. And there's, because we call this side over here C, they call this big angle down here big C. And they then tell us that the area is equal to a half AB sine of C. Okay, So the area of that triangle is a half AB sine C. Now, you should spot, lads, that this comes very close to the old formula for area. That was a half base by perpendicular height. So you should know that formula maybe from junior cert. A half the base by the perpendicular height is kind of the old way we would have found the area of a triangle. And we should be able to spot that H here, that perpendicular height. Well, we can use, we can find that side there because it's the right angle. I don't want to get too much into that because we're doing ordinary level, so we don't need to be able to prove things like that. But yeah, you can kind of, you might be able to see where that formula is coming from. It's not just plucked out of the air. Now, so let's look at an example of this. So if I have this triangle that I'm going to draw here, let's say, just some weird triangle. And I'm told this side is 5 and this side is 7 and the angle in here is 56 degrees. I should be able to work out the area of that triangle. Okay, now, when it comes to doing trigonometry on non-right angle triangles, it's always a good idea to label up the triangle. We're asked to find the area, so we need to use this formula here. And that means we need to know what our A is, what our B is, and what our big C is. So the thing that's going to determine what we label the sides are is this big C, because that has to be the angle we're given. It would make no sense to call that C, because we've no information about it. So we're going to call the angle that we've been given, we're going to call that the angle C. That should make sense. That means at this side over here, that's lowercase c. Because that's lowercase c, then we can just call this guy here A, and we can call this guy here B. It doesn't matter about the order. For example, I could call this guy here B, and I could call this guy here A. It doesn't really matter. So the area equals a half, using this formula from up here, a half of A, which is 7, times B, which is 5, times the sine of C, which is sine 56. So the area equals, into my calculator, 1 over 2 multiplied by 7 multiplied by 5 multiplied by sine of 56 equals so my calculator was set up into radians, so I need to turn that into degrees. So it's 14, area is 14.508. And if these were centimeters, we would have centimeters squared here. So once we label up our triangles, these questions tend to fall apart. Right, so I'm now going to do question 1, which you had last night for homework. Question 1, part 2 maybe. And we have this triangle here. Again, I wouldn't recommend you draw the triangles in your leaving cert, because you could draw it incorrectly. But certainly if there's no information, if there's information given in the question that's not given in the diagram, you should try and fill that information into the diagram that's given. Okay, so, right, it's a non-right angle triangle. Sensible thing to do is label it up. I'm going to use the formula a half AB sine C. I like to give it a capital letter S there to show that it's different from AB, and that will be area Do not write A equals because that will confuse you. Right, so it makes sense to call the angle we've been given the angle C. That means that's lowercase c. That means this is A and this is B. So I can now go area equals a half times 4 times 5 times the sine of 48. And the area equals 1 over 2 multiplied by 4 multiplied by 5 multiplied by sine 48, which is equal to 7.43. 7.43, and I think that's centimeters squared. Let's do the same for question 2. And let's pick question 2, part 3. Now, this is an interesting question because we've been given the wrong information. We've been given the information that isn't directly useful to us. We've been told that that's 14. We've been told that that's 23. We've been told that that's 28 degrees. We've been told that that is 120 degrees. So let's label up our diagram. Okay. Now, if I was to call this angle down here C, that means that 14 is the C. But in my formula, a half AB sine C, I don't need it to know a side C. I need to know the sides A and B. So that's forcing me into calling the sides that I have, they must be A and they must be B. So that means that the 28 is actually the uppercase B, and the A, the 120 degrees, that's the uppercase A. That means that the angle, that big angle there, must be uppercase C, which means that's lowercase c down here. So I need to find the size of this angle C. Now I should know that 28 degrees plus 120 degrees, because they form a triangle, because 128 plus 120 plus the uppercase C must equal 180 degrees, okay? The sum of the angles in a triangle should add up to 2 right angles, yeah? So it should add up to 180 degrees. And that's just a mathematical fact. Again, we won't get into that, why that is the case. That's just the way it is. You should know that from junior cert. So it's 180 degrees minus 120 degrees minus 28 degrees. And that's going to give us, I should be able to have my head, probably 32, is it? 180 minus 120 minus 28 is equal to 32, yeah. So it's 32 degrees. So I now know that that angle up there is 32 degrees, which means I now have a half times 23 times 14 times the sine of 32. Excuse the capital letters, but I think it is kind of a nicer way to do it in this question. And area equals that, just like area equals that formula there. So let's multiply that out. 1 over 2, start bracket 2, 3, close bracket, start bracket 1, 4, close bracket, start bracket, sine 32, close bracket, equals. And that's area equals 85.32. And that's centimeters squared again, isn't it? Yeah, centimeters squared. So that's, yeah, so for the entire of question 2, sorry, for question 2, part 2 and 3, you're missing the angle in between the two sides. So you need to know that angle in between the two sides. And the way to do that is realize that the three angles need to add up to 180 degrees. Okay, so I'm going to assign question 3 tonight for homework anyway. So for question 3, you will find the area of both triangles and add them together. Nothing really weird there. Can I do an interesting question for you? If I do question 7, you guys should be able to do every question up as far as question 7. I think that's when it changes. Okay, question 7. We're told that we have this triangle that looks like this. And we're told we have 37 degrees down here. And we have 12 up there, and we have x down there. Okay. And we're told that the area equals 30. So, non-right angle triangle, sensible thing to do, label up our diagram. That's the angle in between the two sides, so I'm going to call him the angle C, which means that's lowercase c, which means that's A and that's B. So I can now say area equals a half AB sine C. So 30 is equal to a half times 12 times x times the sine of 37. So 30 equals 6 multiplied by sine 37 equals 3.61x, and that's supposed to be 30. So x by itself, well, the 3.61 is multiplying the x, so to get rid of multiplying by 3.61, we divide by 3.61, so it's 30 divided by 3.61. So x is equal to 30 divided by answer, which is 8.31. And that's going to be centimeters, I think. Nope, just units. Okay, so it's 8.31 is the length of B, or the length of X. Okay with that? They will try and confuse you. So if you look at question 9, for example, or question 6, they give you angles called A and angle B. Okay, you just label them up the way you want to label them. So the angle in between the two known sides, call that C. Okay. Yeah, well, I do question 6. I'll do question 6 for you now. Just looking at it, it looks a bit difficult because there's a kind of a twist in it. So question 6 really quickly. So I'm not going to kind of explain this too much until I get to the end. So you should know what you're doing at this stage. 6, 10, and then we're told the area is equal to 29. But this time the unknown is this thing in here. Let's call it A. Right. So I'm going to label up my diagram. I'm going to call the angle that I'm talking about C. I'm going to call this C. I'm going to call this A. And I'm going to call this B. So I know that area is equal to a half AB. That's area, by the way. Half AB sine of C. So area, so 29 must equal a half times 6 times 10 times the sine of A. So 29, I probably should call that big capital letter A theta. That would have been a better thing to do, but anyway, we'll leave it as A because that's what the book gave us. So that's 30 times the sine of A. So sine of A is equal to 29 divided by 30. So the sine of A is equal to 29 divided by 30, which is equal to 0.96 repeating, 0.96 repeating. Now, I have sine A over here. We know to get rid of sine, I do the opposite on the other side, and the opposite of taking the sine of A is to do sine inverse of A. Sorry, the opposite of sine is to do sine inverse on the other side. So A must equal, oh, there's a little dot on top of him. A is equal to sine inverse of answer, which is 75.16 degrees. So that is our, yep, that's it. So that was a little bit tougher because you were looking for the size of the angle. But you already have the skills, okay? You have the algebraic skills to get this down. The only new skill that you are learning really is how to set up this formula. Once you set up the formula, everything you already know will get you the rest of the page, okay? Particularly this thing here. To get rid of sine on this side, we do sine inverse on the other side. Okay, so for homework tonight, I will assign you, every question up as far as question 7, I think. Right, and I'll see you guys tomorrow.